Okay, so welcome back. Okay, so now in this example, now we've got something a little bit more complicated. So here's where you kind of got just use algebraic manipulation to make it fit the way you need it to fit, okay? So we know if we can get this to look like what we would expect for a power series, right, a geometric series, then we can use the formula, right? So it looks sort of like a geometric series, but it's not quite the right form, right? Remember, we have to have it in the form of A over 1 minus R, right? So how do we manipulate this thing to look like something like this? Because we've got a 4 here, we've got x squareds here. We've got to change things, right? Okay, so this is where, again, you're going to have to do trial and error, or you're just going to have to try to figure this out. But let me show you how I would approach this to try to get in here. So I need a 1 here, right? Well, I'm going to have to factor, right? I got a 4 here. So I'm going to have to factor out the 4, right? So if I factor out the 4, what does this give me? It gives me x squared 4 times 1 minus x squared over 4, right? Okay, so it still doesn't give me exactly what I'm looking for. So now I'm going to have to manipulate this because I can't have the 4 there, right? So just because I factor it out, I'm not going to be able to keep it there. I'm going to have to pull this out. So what can I do? I need to get rid of that 4. So I need a 1 there. Well, how can I get a 1 there? I can divide this by 4. So I can divide the bottom by 4, but if I do that, I have to divide the top by 4. So let's divide the top and the bottom by 4. Okay, so if I do that, now this is what it's going to look like. So I'm going to divide the top by 4, and I'm going to divide the bottom by 4, and I'll get rid of that 4. And so I'll end up with 1 minus x squared over 4. Okay, so now, what does that give me? Well, now I can see what my R is and what my A is, right? So that means, so let me box this in. So this is going to be my A, okay? And this is going to be my R, okay? So now, R, right, so the absolute value of R, in this case, is equal to the absolute value of x squared over 4, right? And so this has to be less than 1. Okay? Now, since this is always positive, and this is obviously positive, I can drop the well, no, I don't want to drop the absolute values just yet. Let me rewrite it. Let me write it this way. So this means that negative 1 is going to be less than x squared over 4, and this is going to be 1. Okay? So now what happens? I'm going to multiply both sides by 4. So this is going to mean negative 4 is less than x squared, which is less than positive 4. Now, if I take the square root of both sides, I'm going to get what? Or three sides, I should say. I'm going to get negative, let's see here. Oh, you know what? Yeah, I guess I should have done that. I was thinking right, but I didn't. So let's do this. Because this is always positive, I can drop the absolute values, and I can just say this has to be less than this. Okay? Which means that, yeah, that's it. So then x squared is less than 4, which means what? X is going to be less than or equal plus or minus 4. Oops, I'm sorry. 2. Actually, more appropriately, is the absolute value of x is going to be less than 2. That's what I mean. Because remember, the property, if you take the square root of a square, again, depends on if it's an even root, you want the absolute value sign. So don't forget that so this is going to be the absolute value is less than or equal to 2. And so, of course, we get what we really want, which is this. Okay, now, so that's the radius of convergence, right? So we know that this is going to be negative 2 to 2. Our radius is, not our radius of convergence, our interval of convergence. Okay, so now, what about the infinite polynomial? So now we can write f of x is equal to what? Well, this is our a, so it's going to be the summation of n equals 0 to infinity of what? Well, it's going to be this x squared over 4 times x squared over 4 to the nth power. Oops, hold on. Yeah, that's right. Let me make this a little better. Okay. Now, so now let's simplify this a little bit better. So this would be equal to n equals 0 to infinity, and we would get x squared over 4 times, so now let's write this as 2 squared. So this would be x over 2 to the 2n. And that's the way we would leave it. Okay, so now this converges for all values of x between negative 2 and 2. And so we can write this as what? Well, Guess we can go one more if we combine these. Yeah, see, so here's the A, but if we can still combine these because this is 2 squared. Okay, so we can write this as squared. So if you wanted to, yeah, so we could write this as, and this would be the simplest way to write it. If we combine these, the top is going to become x to the 2n plus 2. Yeah, x to the 2n plus 2. And the bottom, we'll have a 4 here. We can get a 4 here because it'll be 2n plus 2, but we can write it as 4 to the n plus 1. And then, so if we wrote out some of the terms, we go to x squared x squared over 4 plus x to the 4th over 4 squared plus x to the 6th plus x to the 3rd. No, not x, 4. And so on. And there you go. Have a great day.